Hi students, welcome back to the class. So today it will be the last class for unit 1. Okay, and in our earlier classes we have discussed the methods for finding out the concentration of solute in the solution, right? So before starting the class I would like to request you to watch the video till the end, okay? So which will help you guys. Okay. Now in our today's class I will be discussing the another two methods which we have mentioned in our class, so which is reactions in solution, right? Okay, so we have done mole fraction, right? We have done a mass percent, right? So now it's what? Molarity and molality. So I will go through simple concept of molarity and molality with one example of each. Okay, so so we are supposed to discuss the number third one. Okay, and that is what we are talking about, molarity. So molarity is defined by what? Means it's symbolized by or represented by an alphabet which is our capital M. Okay. Now students, when we are talking about molarity, as we have already mentioned it, right? As we have mentioned is that we are finding out what? Concentration of what? Concentration of what? Solute, right? We are finding the concentration of solute. Now you know guys, here when we are talking about molarity, basically you know the solution which forms, the physical state of the solution, probably it will be in your what? Liquid. Okay. Why I am telling these things you will get to know. And whatever the solute and solvent we have, solute basically in what? Solid state it will be. So as this solution is liquid state, right? So definitely what our solvent will be in liquid state, because we have already mentioned that the physical state of the solution depends on the physical state of the solvent molecule, right? It depends on the physical state of the solvent molecule. Okay, now look, what we are doing, you know guys, here, whatever the solute we are having, okay, with that, what we are doing, you know, we are finding the mole of this solute. Okay, we are finding the mole of this solute, and whatever, so if it is in liquid, so we will consider it as in volume, right? We will consider it as in what? Volume. So what we are doing, you know what, when we form a solution, it's okay, right? At a particular volume with some particular mole, we will form a solution. But when the term comes molarity, it means what? Mole of the solute in what? Per liter of the solution. Mole of the solute in what? 1 liter of the solution. That is what we are talking about, molarity. Okay? It is what? The number of moles of solute. The number of moles of this solute in what? 1 liter of the solution is what we are talking about, molarity of a solution. Okay, I hope you guys have understood, right? So what we can mention here, regarding molarity is what? It is defined as the number of moles of solute in 1 liter of the solution or solvent. So whether you can use here solvent term also, okay guys, we can use solvent term also, right? Because when it is solid and liquid, so ultimately the volume of the solution will be defined by the amount of the solvent, right? So you can consider here solution also, or you can consider it what? Solvent also. So so now what we can do is that according to this definition and all that, what we can do, we can represent this molarity with an equation. Okay, so mathematically what I mean, so what we can write, molarity capital M equal what? Moles of solute in what? And what? Volume of solution in what? Liter. So you can consider this as an equation here. Okay, volume of solution in what? Liter. So I hope you guys have understood the concept, right? So what I will do now is that I will go through one of an numerical problem of this. Okay, then we will try to solve it. Okay, so consider let's go through one of a numerical. Okay, regarding this, say a solution is formed by dissolving say 20 gram NaOH in say 500 ml water. Okay, 500 ml water. So calculate the molarity of the solution. Okay, we have to what? Calculate the molarity of the solution, which is formed by dissolving what? 20 gram of what? Sodium hydroxide in what? 500 ml of water. So how we will solve this is that, given, right? First of all, we will start with this. So solute, what is solute here? So 20 gram sodium hydroxide is the solute here, right? So what? Solute, I mean mass of solute, right? Mass of solute means what? Sodium hydroxide is equal to 20 gram given to us. So therefore what? Mole, we have to find out the mole, right? We need the mole to calculate molarity, isn't it? So we are trying to calculate the mole of solute equal to what? 20 gram. That means what? Given mass divided by what? Molar mass. So molar mass of sodium hydroxide is what here? 40 gram per mole, right? So mole will be cancel out. So what remain? 1 by 2. 1 by 2 means what? Half money means what? 0.5, and it will be become your what? Mole. Okay, that means what? It's obvious, right? If 40 gram is 1 mole, then 20 gram is definitely it is half mole, right? So half means what? 0.5 mole. So now what will we do? Now what will we do? Volume of solvent, or you can consider solution, right? Because I have already told you why we are supposed to mention the solution, isn't it? The volume of solution equal what? It is given whatever 500 ml, but we are not supposed to calculate it in ml, right? We are supposed to calculate in terms of what? In terms of what? Liter. So we are dividing by 1000, okay, and it will come out as what? 0.5 liter. Okay, so therefore molarity. So therefore molarity, capital M equal what? Mole of solute. So what is the amount of mole of solute? So 0.5 mole, right? Divided by volume of solution, it is what? 0.5 liter, which is equal to 1 mole per liter. So what I can say you here, SI unit of molarity equal what? Mole per liter. So this is another point which we have to remember here. Okay guys, so I hope you have understood this problem, right? So this type of numerical may be the question for your final examination. Okay, so you have to go through this thing. It's very simple, guys. You have to calculate the mole of the solute. Okay, and whatever, if it is given in liter, so no problem, right? Or if it already in liter, then no problem, right? But if it is in milliliter, right? So you have to convert it into what? Your liter. Okay, so this is all about your molarity of a solution, or how to calculate the molarity of a solution. Now the next thing which we are supposed to discuss is what? Molality. You know what? Molarity and molality is somehow they are the same, but you know what? In case of molarity, basically the solution, I mean the physical state of the solution, obviously it is in what? Solid state. Why, you will get to know. Okay, so solute, it also in solid. I think solvent will also be in what? Solid. So that's why it becomes solid, right? Because what says, you know what? So solid, you have to calculate what? Obviously again you have to calculate the mole. But whatever the solvent given to you, it's, you know guys, you have to convert this into what, in terms of what, kilogram. What I mean is that moles of solute in what, per kg of the solvent. That is what our molality. Got the logic, guys? Moles of solute in what, per kg of the solvent. That is what our molality. Look, in molarity we are taking what, liquid, right? So this is a per liter of the solution. Here what, per kg of the solvent only here, only solvent, okay, not solution. If you're solution, then you have to consider both, but we are not considering both. So that's why I have told you in the earlier case that either you can write solvent or you can write solution, because it is a liquid one, right? Earlier solvent is what, liquid one. So it will define the volume of the solution. So you can take solution also, solvent also. But here when you mean solution, you have to calculate, means add both the thing. But here we are not supposed to do that. Here we are just supposed to what, talk only about solvent. Okay. So what we are saying, look guys, that molality is what, moles of solute in what, per kg of the solvent is what your molality. Okay. So how we can define all these things then? Molality, it is defined as the number of moles of solute in 1 kg of the solvent. Okay, it is defined as the number of moles of solute in what, 1 kg of the solvent. So this is the concept, guys, okay, and this is the difference between what, molality and molarity. Okay, in molarity what we are doing, we are considering per liter, right, as this solvent is in liquid state, and here as our solvent is in what, solid, so obviously it will be given in gram. If it is in kilogram, no problem, right? But if it is in gram, then you have to convert it into kilograms. So what we are doing, moles of solute in per kg of the solvent is what called your molality. Okay, so is this is the thing, then how we can represent molality then? So molality is represented by small m. Okay, small m equal what, moles of solute divided by what, mass, right? Mass of solvent in what, kg. Okay, mass of solvent in what, kg. So this is how we represent molarity unit with the form of an equation. Okay, so let's go through one of the numerical. Okay guys, then we will end the class for today, and this will be the end of this particular unit. Okay, consider 90 gram of C6H12O6 is dissolved in 400 gram of water to form a solution. Calculate the molarity of the solution. So this is the question. Okay guys, so let's try to solve the numerical. Okay, it's very simple. Look, 90 gram of C6H12O6 means what, it is glucose, right? And 400 gram what, H2. So it is 90, it is 400. So definitely 400 gram of water will be what, it's solvent, right? So what we will do, given mass of solute. So what is solute our C6H12O6, which is glucose, right? It is given what, 90 gram. So therefore what, mole of solute, it will be what, given mass 90 gram divided by what, molar mass. So molar mass of this will be what, your 180 gram per mole. Okay, if you supposed to know how we have calculated this, then 6 carbon, right? So 1 carbon means 12 plus 12 hydrogen, right? So 1 hydrogen 1, 6 oxygen, right? So 1 oxygen 16. So 72 plus 12 plus 96, right, which is equal to 180. Okay, so this is how we are supposed to calculate the molar mass of C6H12O6. So now what will we do? Now what? Mass of solvent. So mass of solvent, it is given in our what? Gram unit. So we are supposed to convert it into kilograms. So we will divide it by what? 1000. So it will become what? 0.4 kg, right? 0.4 kg. Sorry guys, I forgot to here. So 90 by 180 means what? 0.5, right? Think about it. If 180 means 1 mole, so 90 means obviously it is half mole, right? So it's obvious. So therefore what we can do? Therefore molality equal what? Moles of solute. So moles of solute 0.5 mole, right? Divided by mass of solvent. So mass of solvent, it is what? 0.4 kg. So which is equal to what? 5 by 4, right? So if you divide 5 by 4, it will be 1.25 and what? Mole per kg. So from here, from this numerical, we have get to know one more new thing, that is SI unit of molality equal what? Mole per kg. So this is the new thing which we have known now. So this up to here is the numerical. Okay, so I hope you guys have understood these things, right? So this will be the last class of our unit number 1. If you are having any problem, so then you just try to contact me. Okay, so thank you so much.